So we have our furnace or our air conditioner or our heat pump, and now we need to distribute that warm air or that cool air throughout the house. And this is our distribution system. ASHRAE tells us that we have to keep the air moving, and a big reason is for health. We need to have clean air coming through constantly, and we can't have pollutants building up. But the other reason that air must be kept moving is because it will stratify if you don't keep it moving. It will form layers. As you know, warm air rises, cool air sinks, and if you don't have that air moving, you're going to have cold air settle on the floor, hot air settle on the ceiling, and you got these layers. So we keep that air moving. And by the way, in the next PowerPoint, we're not going to talk about the next PowerPoint together, but I'm just telling you that it's in the lectures folder. It's called ventilation, and it has some standards, some numbers from ASHRAE about how many cubic feet per minute are suggested, how many air changes per hour are suggested. So if you need those numbers, go look at that PowerPoint. All right. So here's this picture again you saw last time with the distribution system. We've got our blower here, our fan, and it first of all sends air into the plenum, that central chamber that takes that air from the blower and distributes it out into the ductwork. And let's say it has blown hot air into your house, and that air has cooled off. Now that cooled off air gets pulled back in through the return, and it returns back to the furnace to get heated again. If you have a heat pump doing some cooling, you blow cool air into your room, it heats up in the summertime, and that heated up air comes back into the return and goes back into your heat pump to get cool again. This return air side of the system is really important for keeping the air pressure balanced, so we don't have any suction or excessive pressure. It keeps the temperatures all evened out, and as the return air comes through here, it goes through filters, and those filter out the dust and pathogens and make your air healthier. Now, return air moves more slowly than supply air. The return air registers are bigger than the supply registers. So you can go into a house and look around, and if you see some registers in a room, some of them are smaller, some of them are bigger, right away you know those bigger ones must be the return air. And you can well, maybe you don't want to impress people, but if somebody asks you, you can say, oh yeah, that's the return air. How do you know? Because it's bigger. In our climate here, where we have both heating and cooling, we put supply registers that blow the new air into the room. We put the supply registers along the outside of the walls, and we put the return registers towards the inside. We don't want to be pulling in return air from the freezing cold outside if we're trying to heat our house. That doesn't make sense. But we do want to take, if we're trying to heat our house, we do want to take nice hot air and blow it out against the cold outside walls and start to warm everything up. So you'll see supply registers usually along the outside walls, depending on what part of the country you're in. And you'll see these return registers. Different technicians will locate them different places, but they're always bigger. That's how you can spot them. Then we've got registers, these things with slats in them that distribute the air into the room. And they might have dampers behind them, these adjustable thingies, so you can adjust the airflow. And then it's the ducts themselves that they're like big pipes for the air that carry the air into the rooms of your house. They can be made of sheet metal or they can be made of fiberglass sheets actually, and they come in different sizes. And we can arrange them in different arrangements. The tree with branches idea, so a big trunk and some smaller branches, or a loop where we run the duct around the outside and put the supply registers against the wall. You'll see that especially if you're concerned about heating. Or a radial system like this. Whatever system we do, we're concerned about making sure this ductwork is big enough. If it's not big enough, you're going to get high velocity air, and so it's going to blow too fast and it's going to whistle. Nobody wants that. Here's an idea that you will see over and over again in your design career. This idea that we want round corners, the bigger the radius the better, in order to prevent turbulence. And you will see this in plumbing. You'll see this in design of plastic parts. If you do plastic injection molding, where the mold machine squirts liquid plastic into a mold, we want round corners. If you're doing cast iron, casting of metal, we want round corners so the liquid metal goes around the corner. And when we're designing ductwork for air, we want round corners so that the air will move smoothly and not be turbulent. B in the upper right corner here has sharp corners, and that causes turbulence, and that causes the air not to flow very well. And finally, as I mentioned, it's worth repeating, we need to make sure that we size our ducts correctly. So do not let people have the idea that we'll save some money if we just go with smaller ducts. That is never going to work out. You need to figure out how many CFM, this is cubic feet per minute, how many cubic feet per minute do you need entering your room, and what shape is your duct, and what is the capacity of your heat pump or furnace or air conditioner, and you just have to size the stuff accordingly.